Welcome to the How to Program with Java podcast, where all you need is the desire to learn, and you too can become a Java programmer with absolutely no knowledge of programming. And now, your host, Trevor Page.
Hello, ladies and gentlemen, boys and girls, children of all ages. You have reached episode number 54 of the How to Program with Java podcast. And as the booming voice in the intro alluded to, my name is Trevor Page. So, welcome. Today we are going to continue our journey down the Hibernate rabbit hole. And more specifically, we're going to be sort of extending our last talk in the last episode on the topic of relationships. Now, we're going to be talking about annotations and how to specifically map a bidirectional one-to-many relationship, again, using Hibernate. All right? So if you have no idea what I'm talking about, you'll probably need to go back a few episodes to the start of this Hibernate conversation. If you don't know what a relationship is in terms of database relationships between two tables, then you probably need to go back even further to when I start talking about databases. All right? So, cool. Now, what's happening here, what's a little bit special about this episode is I'm actually recording this quite a little bit in the future because I'm actually going to be on vacation next week, which is very exciting. This is like the first time I've actually gone on a real, true vacation where I'm actually going to be shutting off and unplugging and getting out, into nature and sort of recharging my batteries. So, having said that, I'm getting caught up on all the work that I'm going to need to be posting next week, and I'm doing it now. So, having said that, I don't have any reviews to give to you guys or to talk about. So if you had left a review and you haven't heard me obviously talking about it now, it's because I recorded this too far in the future, and I will get it on the next episode. So if you are interested in leaving a rating and review, I would love you to do it. You can go to howtoprogramwithjava.com/love. LOVE, and you can leave a rating and review. I will read any 5-star review at the top of the next episode, and people seem to love when I do that, so I'll give you the shout out. If you want to, just leave your name in the review itself, and I will absolutely give you the nod for the rating and review. All right, so let's get into the meat and potatoes. We are, like I hinted at, going to be talking about the bidirectional relationship now. So we were talking previously about the unidirectional, which just meant that, in terms of our example that we were talking about last time, we were using the example of employer and employee, where one employer could map to many employees. But what we had done when we had mapped out the unidirectional relationship, which means just one direction the relationship can actually map to, we mapped it from the many to the one side. All right, so we mapped it from the employee to the employer, because like I said, there are many employees, there is one employer. So we mapped it, the unidirectional relationship, sort of from the right-hand side to the left-hand side, from the child to the parent, from the employee to the employer. All right, so what's different now with the bidirectional relationship is that we are going to have to map both sides of the relationship. So not only from the employee to the employer, via the employee.getEmployer method, but we're also going to be mapping it the other way around from the employer to the employee via the employer.getEmployees method. So the critical thing that you need to understand is that there is a difference between the relationship from the many side to the one side and from the one side to the many side. Now, what I mean by that is let's take a look, or rather let's think about the code that we had written previously for the employee class. So that's from the many side of the relationship. The employee class defines an instance variable called employer. All right, now that employer variable, it has the type of employer, right? That holds the type of the class that we had created for the employer object. All right, now the thing to note there is that it's singular. There's only one employer, which makes sense. That holds true with how this relationship should work, because any one given employee should only map back to one employer. Does that make sense? Only one employee can map back to one employer, because that is the restrictions that we have placed on this particular relationship. It is a one-to-many, and therefore it is also a many-to-one. So if you pick any one employee, it should only map back to one employer. So that's why we only have a single employer type object listed inside of the employee object, okay, inside the class definition. So now, having said that, that's the one end of the spectrum. Now we're going to be looking at the other end of the spectrum, the bidirectional part, where we are looking at the from the one side to the many side, all right, from the employer to the employees. Now the difference here is that any one given employer could be mapped to 0, 1, or many other employees. So how we actually create this or recreate this relationship inside of Java using our Java objects, we actually include a collection of employees inside of the class definition for the employer. All right, I'll say that again. Inside of the employer class, which previously we didn't have any tying relationship over to the employees, now we are introducing that relationship, that tie-in with the employees, and we are introducing it in the manner, in the way that we're actually including a whole collection of employees inside of the employer. Again, because that makes sense. Any one given employer should map to several, possibly several employees. So how do we represent several objects together in one place or whatever? It's together in one type, in one actual, Java type. And we do that using Java collections. So what I mean by collections is that it's either going to be a set or a list. All right, we're finally talking about real, core Java stuff again, a set or a list. Now, you can go back and forth with either one. Usually the best practice is to use a set, because if you use a list, some funky stuff can start to happen when you have the actual, multiple relationships building up in there. I don't want to get into that now. We'll get into that when we start to talk about more, advanced topics inside of Hibernate. It's not really an advanced topic. Really, the side effect of this is that you'll have too many references inside of your mapping. So you'll have several mappings to the same employee, which wouldn't really make sense. So you need to do a little bit of extra coding when you're accessing or loading the information via the DAO. But again, I don't want to get into that. We'll talk about that later. So what I'm going to focus on is, because using a list collection tends to cause a bit of side effects, I'm going to focus on using the set collection. Okay, the set collection ensures uniqueness, so it gets rid of that problem that I was just sort of alluding to about having, duplicates when you actually invoke the relationship. So that's why we're going to focus on using a set. So inside of the employer class, the employer.java class, inside of the class definition in the code, we are actually going to include a set of employee objects. So we're going to create an instance variable where it's going to be a private set of employee objects, and we'll give it the name of employees with an S on it, so employees plural. All right, so that's just we're creating an instance variable just like we had created any other instance variable. It's just the type of this variable is going to be a set, and like I said, it's going to be a set of employees. So it's going to be set, and it's going to be open your less than use the less than sign, which is sort of an open bracket type thing ish. It's for if you've used collections before, I'm sure you know about using collections and assigning the actual type that you're going to be, or specifying the actual type that you're going to be storing in the collection itself for type safety. So you're going to use the set less than sign, then you're going to say employee, then greater than sign, and you're going to assign it the variable name of employees. And then, just like any other instance variable, you create getters and setters. So you'll create a getter method and a setter method for the employees instance variable. Okay. So with the getter and the setter, and as is always constant with Hibernate, of course, uses an annotation to mark their functionality. So we are going to use an annotation to mark this relationship functionality. So just like we use the @many-to-one annotation inside of the employees class, okay, we had annotated the get employer method on the employees class. We annotated the get employer method with the @many-to-one annotation, and we had assigned a cascade to it, the cascade all. Okay, so that we cascade our inserts and our deletes and everything to maintain the proper structure of the database. So the same thing applies here on the flip side. So now we're looking at the flip side, which is the one side of the relationship, okay, which is the employer side of the relationship. So like I said, we have established our instance variable, which is the set of employees with the getter and setter method. So obviously, just like we did it in the employees method, on the employers, or I should say employees method, employees class, in the employers class, in the get employees method, or rather on top of the get employees method, we will put the one-to-many annotation. So we will put at one-to-many on top of the get employees method of the employer class. Okay, so at one-to-many on the get employees, just like we had at many-to-one on the get employer in the employee class. Okay, there's a lot of employee-employer going on, but again, once you see it in person or see it in code, it really makes a whole lot of sense, because you have two different relationships, two different getter methods, and two different classes, both pointing to each other via the appropriate annotations. The right-hand side has at many-to-one, the left-hand side has at one-to-many. Okay, at one-to-many, at many-to-one. Makes sense? They point to each other. So on top of that, so if you were to put that annotation there, you put the at one-to-many, and you assign your cascade of being, cascading all, then you will almost be done. And you could even get away with doing it this way, but the only problem is when you do it that way, Hibernate gets a little bit confused and actually tends to really make some weird stuff happen in your actual database. So we're missing one more small property that we need to assign on the parent side of the relationship, okay? If we don't assign it, then what happens is Hibernate will create a third table. So it creates sort of like a mapping table. And that would be fine if we were dealing with a many-to-many mapping situation. Because if you remember way back when we were talking about the many-to-many relationship, when we were talking about just plain old databases in SQL, the many-to-many relationship requires the adjoining, the mapping table to map out the associations between the two different tables. So, if we do it this way, if we go ahead and just put at one-to-many on the parent side and specify a cascade and that's it, then what happens is Hibernate creates a mapping table. But not only does it create a mapping table, but it also puts the foreign key inside of the child table. So it puts the foreign key, which is the employer ID, onto the employee table. So it puts two different practices into place to find out what the actual mappings are. And that's just bad. That's bad database design. That's bad coding. So, you could get away with doing it this way, but it's a very lazy way, and it's very, very easy to address that issue, okay? So I would almost go as far as saying that without this one next piece of information that I'm about to teach you, without putting it in there, you actually have incorrect code, okay? So, very, very easily address this issue, no problemo. I just wanted to, establish the fact that the two can almost be very symmetric in terms of, on the left-hand side, on the parent side, we have the at one-to-many with a cascade, and on the right-hand side, the child side, we have the at many-to-one with the cascade. So they almost are identical in how you put the coding in. But the one exception, there's always got to be an exception, the curveball, is that you need to assign a mapped by property on the parent side of the relationship. So when you specify the at one-to-many annotation, inside of the round brackets, you're going to put the parentheses, you're going to put the cascading, and then you can put a comma, and you're going to say mapped by. Okay, mapped, M-A-P-P-E-D, mapped by, all one word, equals, and you're going to put a string in after the equal sign. So what you're doing here is you're telling Hibernate how to properly map the two together. So in order to join properly, to tell Hibernate which and how exactly these two join together in the bidirectional relationship, we need to insert the name of the variable that we use to map from the parent to the child inside of the child class. So the child class is the employee object, and the employee object, as you remember, hopefully you remember, we put the employer's instance variable, okay? And we called it employer. We called it employer with a lowercase e. That's the variable that we need to tell Hibernate that we used inside of the child class for the parent class, okay? So what the parent class needs is the parent class just wants to know how exactly it was mapped via the actual instance variable's name inside of the child class. So we need to say, okay, mapped by equals, in quotes, employer. Okay, employer with a lowercase e. Because, like I said, and I'll emphasize again, that is the name of the variable that we used in the child class. If we had not called it employer in the child class, if we just called it, EMP for short, then on the parent class, we would need to emphasize that inside of the mapped by. We would need to change it to mapped by equals EMP. Okay, again, if we had changed the name of the mapping, related mapping on the child side of the relationship. All right, and that's it. That's all we need to do. We just need to add that mapped by property on the parent class, on the at one-to-many annotation. All right, and then we're good. Then we're done. We are completely finished in terms of the mapping side of this equation. So to go back to the mapped by property that we're putting inside of the at one-to-many annotation, that mapped by property you will see across all of the bidirectional relationships. So if you have a one-to-one bidirectional relationship, you're going to need to tell it on the parent side what it's using for the mapped by, so how it's mapped in the child class. If you're using a one-to-many, just like we're using now, bidirectional relationship, then on the parent side, you need to specify how it's mapped. And of course, just as you've learned, we use the mapped by property to do that. Now, the one curveball, again, just to throw a little bit of salt in the wound of your learning process for Hibernate, with the many-to-many bidirectional association, you don't use a mapped by property, but the fundamentals still hold true. So you still need to tell the one side how it maps itself on the other side, but you kind of need to tell it on both sides of the mapping because it's many to many, so it's a little bit more complex. So you need to tell the left hand side how it maps inside the right hand side, and you need to tell the right hand side how it maps inside of the left hand side. I don't want to get into that right now. That's totally going to be something we cover in a future episode, maybe the next one, because I think the one-to-one relationship is going to be fairly straightforward because it's very similar to the one-to-many, except for, of course, a little bit of special sauce inside of the way that we do the foreign key, primary key thing that is unique to the one-to-one mappings. So maybe we'll talk about this in the next episode, maybe not. I have no idea. We'll see how far I get. Okay? So, very good. So you need to understand just the basic concept of the parent side needs to understand how it's mapped inside of the child side. All right? So, how does that relate, or how does that apply itself now? How does that change things, rather, when we are actually invoking the whole persistence process, when we're actually trying to save these objects? What needs to change? Well, obviously, something needs to change because I'm talking about it. So previously, we had an employee DAO. Okay, and the employee DAO had a save method, which took an employee object, and it persisted the employee object on the session. Okay, but now what we're doing is the way we save actually changes. So like when we had the unidirectional relationship with the at many-to-one annotation, we were saving our objects using the child side of the relationship. So we saved each employee object individually. So we'd say, we call employee DAO.save employee1, and we called employee DAO.save employee2. So we would invoke two different saves on the two different, or however many different employee objects we had to play with, which is the child class. So again, to stress the same point again, we needed to save the child class individually over and over again for however many child classes we wanted to persist. Now, this concept changes, we flip it on its head when we're dealing with a bidirectional relationship. Because now what we do with a bidirectional relationship is we no longer save it from the child side, we can save it from the parent side. Mostly because it's easier to do it that way. Instead of having to save all the individual child parts of the relationship, we can just save the parent once and it will go and cascade and save all the children appropriately. We should always save the children, right? So what changes here is we no longer will use an employee DAO, we're going to use an employer DAO. Okay, but the actual code is going to stay pretty much virtually identical. So the employer DAO will still have a save method. That save method will take the single employer object, and we will still persist it on the session by doing a session.save, and we'll pass in the employer object. Okay, so it's exactly the same thing as the employee DAO class, only you just substitute the word employer or employee for employer. All right. Or is it employer for employee? Anyway, you get the idea. So that doesn't change, really. What changes, the fundamental change, is inside of the code that we use to actually persist all this data inside of, I'm using the controller class. So inside of our controller is where we actually go through and do our saving. Now, what we had done previously was we had actually gone through, we had instantiated a parent object, and then we instantiated the child objects. We saved the parent object into each of the child objects, and then we saved each of the child objects. Okay? So we instantiated the parent object, and then we instantiated the children, and then we assigned the parent into the children, and then we saved the children. All right? But things are a little different now that we have a bidirectional relationship. So what I've just sort of explained to you was the old way that we had gone about actually handling the saving process when we were dealing with a unidirectional relationship. So the point I'm getting across, the point I'm saying over and over again, is that things change in terms of having to save the actual objects, persist the objects, when we're dealing with the bidirectional relationship. So really the million-dollar question is, well, what the heck changes? So, the main changes are in the fact that we no longer are saving the individual child objects. We're saving the parent object. And the fact that now the parent object holds a relationship, holds a reference to the child objects. Okay? Because we added inside of the employer class, we added the set of employees. So now we need to actually recreate that entire relationship, recreate that scenario inside of our Java code. So basically, the structure that we need to follow here is quite universal when you're dealing with the one-to-many type relationships and you're dealing with the whole mapping, bidirectional mapping thing, okay? So I believe this is quite universal when you're dealing with bidirectional mapping in general, okay? I believe it applies to one-to-one, one-to-many, and even many-to-many, if I can think. I believe it does apply to many-to-many as well. But of course, we'll get into that when we talk about many-to-many later. So what is the universal process we need to follow when we want to map and persist our bidirectional relationship? Well, the first thing you do is you instantiate or you load the parent object, because this situation applies also if you want to make a change, right? You got to load up the parent object. Let's say you want to make a change to an existing parent-child relationship in terms of the data in the database. You're going to have to load up these objects to make them, to attach them to your session. Okay, you need to be working with objects that are attached. So the way we do this is then we would invoke a load. So the statements that I'm explaining here hold true for both creating a brand new one as well as modifying an existing set of data. So step 1, you instantiate or load the parent object. Step 2, you instantiate or load the child objects. Okay, then you set the parent into the children. All right, again, nothing really has changed here. This is exactly the process that we followed previously. So we set the parent into the children. But here's where things get different. So that only handles one side of the relationship. If we set the parent into the children and then call it quits, that's just a unidirectional relationship. That's not good enough. So for bidirectional, we have a few more steps. We also need to create a collection of child objects. Okay, and then we need to set that collection of child objects onto the parent, and then we save the parent. Okay, so I'll say that again. We load the parent object, we instantiate parent, we instantiate or load the child or children objects, and then we set the parent into the children, Same old, same old. But then we create a collection of children objects, okay? Which is the collection that we're talking about. We will instantiate a set. So we will say set employee or set of employees, call it whatever you like, call it employees, equals new hash set, okay? We can use a hash set, but you can use whatever set you like. If you want to use a tree set because you want to sort things appropriately, then by all means do that. There's a few extra tricks to actually implementing sorting properly. I guess that's another topic we will have to touch on with Hibernate. Sorry, my throat's getting dry. I need to take a sip of water. So you need to, in any case, we'll use the hash set. So we instantiate a new hash set, which is a hash set of employees, and there we go. So we've just created a collection of child objects, but we also need to populate that collection with the previous child objects that we just created. So if we created, employee 1, employee 2, employee 3 with, 3 different people, let's say Trevor, John Doe, and Jane Doe, 3 different employees, we need to take each of those employees and add them to our new collection of employees. So we'll say employees.add employee 1, employees.add employee 2, employees.add employee 3. All right, so we put all the employees onto that collection. And then we take that collection of employees, so that set of employees, and we put it into the parent object, right? So we will invoke employer dot set employees, plural, and then we give it that collection because it's expecting a collection. It's expecting a set of employees. So we'll give it a set of employees. We give it the one that we just created, the hash set that we just created and stored all of the employees into. We put that onto the parent object. Okay? So now you see how we've recreated this scenario. We've recreated this relationship in our Java code. We have the employee object, the employer object, which we've created, called whatever you want to call it. Could be Google, could be Yahoo, could be whatever. I think I called it employer 1 because I'm not very creative. And then we have also on the employer, we have a set of employees, which actually properly has included inside of that set a reference to employees 1, 2, and 3. Okay, Trevor, John Doe, and Jane Doe. All right, 3 objects are inside of that collection. And then if you go on the other side and look at each of the other objects, so we look at Trevor Page as the employee, he has the employer number 1, set into itself, that particular object. Also, Jane Doe and John Doe will each have the same reference to the employer set inside of them, right? So we have all these different objects that all point back to each other's proper channel through the proper relationship, right? The employer points to the employees each individually point back to the same employer. One to many, many to one. Okay, hopefully you're bashing your head against the wall saying, for the love of God, stop saying this, I get it. So hopefully that's a good thing if you're doing that. So now we're in a situation where we have everything we need. All the objects are properly loaded. All the objects have all the proper relationships assigned to them. All that's left to do is invoke the save. So what do we do here? Well, we save the parent. Okay, I'm not sure if you can save the children. You might be able to save the children, but I can't recall if there's any strange side effects from that. But it's easier to save the parent because let's say you have 100 employees. It would be a big pain in the butt to have to go and save each one of those 100 employees every single time you make a change. So instead, you just save the parent. And then what happens is Hibernate will have the parent, which has a reference to the collection of employees, which is the set of employees. And it has, properly populated with all the real objects. And then all those objects point back to that same employer. So Hibernate will know exactly what to do to actually persist all these changes into the database. All right? It'll handle everything for you, which is absolutely incredible. It saves you so much work and effort. It all comes down to one save, and then boom, you're good to go. All right? So, and that's pretty much it. That's pretty much all you need to do. Now, I can go through every single line of code with you right now, vocally through the audio medium, but that would be a big pain in the butt, that probably wouldn't translate well. So obviously I will direct you to the howtoprogramwithjava.com show notes page, and you can get there and see all this code in the lovely post that I put together for you guys. Again, I'll note ahead of time in the future, I'm being very good and very disciplined and making sure that I'm doing all my work while I'm going to be on vacation ahead of time. So you can go to howtoprogramwithjava.com/session54. All right, you'll see all the notes there, all of the code, as well as a regurgitation of all this information in textual format. So if you prefer to read it, then by all means you can go ahead and read through every single word that I wrote. And I urge you to do that because I think I wrote 1,300 words today is what I wrote. So anyway, that's a great little post. So you can go there, check it out, see the code, understand it, recreate it yourself, and test it out on your own computer. And if you have any issues, then please let me know. You can just post on the blog itself, leave a comment and say, hey, I'm hitting this issue, and I'll see if I can debug it for you. But if you follow exactly the code that I've outlined for you already, then you should not run into any problems. All right? Excellent. Cool. So I guess I will wish you all a wonderful week ahead of time. Like I said, I'm going to probably be unplugged and I'm not going to have access to my email. So if anyone actually sends me a comment or whatever between, July, this post is going on July 28th. So anywhere between July 28th and August 4th, I will be off for the week, and if you see me responding to you, then you should slap me on the nose and say, Trevor, you're on vacation, stop talking to me. But who knows, I might have some limited email access, and I might want to reply back to some people, but who knows. Any case, I will, go to the show notes page, howtoprogramwithjava.com/session54. Hop on the email list if you haven't done it already, because I'm now getting back into the habit of, letting you guys know as soon as this new content goes live, because I've been, creating new content for the past, since May now. So what is that? May, June, July. So 3 months I've been putting all this stuff together, and I haven't been emailing you guys to let you know that it's been live. So a lot of you don't even realize that all this content is being posted. And that's just silly. That's the whole reason why you're on the email list, is to know when a new post goes live, a new podcast episode goes live. So hop on that email list. You can see it. It's going to be either at the very top of the page when you get there. I'll have a little bar at the top where you can put in your email address, or it will be at the bottom of the post. So if you scroll down through the post, eventually you'll see a pop-up will come just above the comments section, and you'll be able to leave your email address in there for me to join the mailing list. And when you do, I send you a lovely resource. It's a one-page PDF on the top 7 tools that Java professionals use every day. So you'll be able to see exactly what tools you need to install on your computer to be successful as a Java programmer. Sound good? Sounds good. So take care, guys. Love doing these things. Can't wait to do the next one after I've been, nice and relaxed and ready to rock after my vacation. If you're interested, I'm actually going down to New York State. So I'm going to New York to, there's a sort of I forget what it's called. There's a lake there with a bunch of wineries. It's probably, the most popular one. I think it's in the northern part of the state. And I think I'm going to Bloomville and Ithaca, and I forget where anyway, I'm kind of bouncing all around in that area of New York, and it's going to be great. I've actually never been to New York State before, or if I have, I've just driven right through it to go south. So this will be my first real visit to New York State. I'm quite excited, and if any of you guys are in New York, I guess shoot me an email and say, hey, I might just read it. So that will be wonderful, and hopefully I'll come back to you guys, like I said, on August 4th, nice and rested and relaxed and ready to rock with the next podcast episode. So until then, take care of yourselves, have fun, and happy learning. Bye for now.
Thanks for listening to the How to Program with Java podcast. Please visit howtoprogramwithjava.com for more useful Java tutorials.